Jai Hind to all of you. I am Dr. Rahul Bansal from Ajay Kumar Garg Engineering College. So this one is the next video lecture for the electronic devices KEC 301. So let us start. So in this video lecture, we will be discussing about the basics of FET, that is field effect transistor, right? So basic diagram for the FET is this is basically the gate. This is source. Right, and this one is connected. So this voltage is said to be VGS. I'm just denoting this by plus minus VGS, although this plus VGS denote this negative terminal is applied, that is VGG is negative, right? So why I am connecting this as like negative, I will let you know what is the physical significance of this, right? Right. So this is the schematic diagram for the FET. So I can write this here. Right. So FET consists of gate. This side, these two sides are gate, right? And this side is like drain, and this one is source, right? So source is basically used to generate the majority charge carriers, right? And these majority charge carriers will be moving from the source to the drain, right? And this gate to source voltage is used to control these majority charge carriers, right? So there is a different color pen. Okay, so whenever VGS equal to 0, okay, then this channel, right, this is the complete channel, okay, through which this charge carriers from the source will be moving towards a drain. So this is the channel, right? So whenever VGS equal to 0, maximum number of charge carriers from the source will be reaching from the source to the drain, right? So that the current which is moving from drain to source, if I say this one is ID, drain current, right, it will be maximum, right? And this maximum current is called as the drain to source safe current or drain to source saturation current, right? So this is denoted by, if you read the standard book, it is denoted by IDSS, right? So drain to source saturation current, or drain to source safe current, right? So this current will be maximum whenever VGS equal to 0. This VGS is connected, that is N plus is connected to the negative terminal of the battery. It means that this FET is working in the depletion mode, right? And all the FETs all the JFETs, junction field effect transistors, are always work in the depletion mode only. That is, negative VGS is only applied. For this negative VGS, maximum current, that is equal to IDSS, which is applicable only when VGS is equal to 0. Now, if I increase the value of VGS, right? If I increase the value of VGS, correspondingly reverse biasing of this P side and N side will be increased, and depletion layer will be formed in the channel. So why it is forming in the channel? Because this gate side N plus is highly doped. The depletion layer will penetrate more into the that region which is lightly doped, right? So this P side is lightly doped as compared to this N side, so that the depletion layer will penetrate more into the channel, right? It will be wedge shape, right? So similarly for this side also, depletion layer will penetrate more into the channel. So if at all effective channel length is reducing, right, due to the applied of this, due to the increasing in this VGS value, right, this is called as channel length modulation, right? So with the effect of this channel length modulation, what will happen is, the charge carriers that were reaching from the source to the drain, it will reduce. Correspondingly, the drain current will also reduce, right? So if we see the drain characteristics, if we see the gate characteristics, sorry, input characteristics, that is gate characteristics, so it will look like negative VGS is applied. Okay, so this is the IV characteristics. Now, if you see carefully, this ID is decreasing if I increase the value of VGS, that is negative VGS, right? A point will come, a point will occur when this channel will be completely disappear, or you can say complete depletion layer will be formed, right? And it will cause the depletion layer, it will cause the channel length to be disappear. This condition is called as, this voltage is called as VGS off, or you can say VGS cutoff, right? And this maximum current whenever VGS equal to 0, it is called as IDSS, drain to source safe current, or drain to source saturation current, right? Now, next is, if I change the value of, if I take this VGS constant and if I change the value of VDS, right? So the characteristic which is formed is called as drain characteristics, right? So now I will change the value of VDS now, and I will check the ID current, what is the effect, right? So for a small value of VDS, ID will increase linearly, right? And if we further increase the VDS value, then an electric field will produce in the channel. It will cause the drain current to be saturated, right? So this is the drain characteristics for FET, right? So the region where this ID is linearly increasing, approximately linearly increasing with the VDS value, this region is called as triode region. Right. Okay. So here is one more point, that is pinch off point. At this pinch off point is basically the minimum value of VDS for which ID enter into the saturation, right? So this point is called as pinch off point, right? So above this pinch off point, the VDS value will be saturated, that is ID value will be saturated. It is the minimum value of VDS, right? So these three characteristics are for different value of VGS, right? So as VGS increases, correspondingly ID will decreases. So these are for different value of VGS, right? And the region where ID is saturated is called as the saturation region. So let me use a different color pen for this. Right. So these are the input and output characteristics of the FET. Now, if I take the if I want to represent the drain current mathematically, so mathematically it is represented as ID equal to IDSS 1 minus VGS divided by VP whole square. So this is the mathematical expression that relate these VGS and VP and IDSS. So you can see from this mathematical expression also, this ID is related to this VGS in the square manner, right? So we say that the FET is JFET is a scalar device, right? So this is also called as right, and this JFET is always work in the depletion mode, right? In the next video lecture, we will be discussing about the MOSFET. The MOSFET works in the depletion mode as well as in the enhancement mode. So we will discuss both the type of the modes, right? Thank you all of you. Thank you.